Hello guys, welcome once again to Engineering Aid. That's the name in the YouTube channel. And please just remember to subscribe, like and share to my YouTube videos. Thanks. So today we will try to see how we can determine the foundation, the depth of the foundation, because we realize that normally most of the uh, engineers on site, or the guys that in charge on site, normally what they do, they just estimate that, let's use for instance 3 feet, that's a meter, let's use 2 meters for foundation, by visually observing uh, the soil. And that is not the case. We have a guy named as Rankin, and Rankin introduced a formula, and actually you can find more about Rankin in International Standard Code from 1080 to 1982, whereby Rankin, in fact, Rankin stated the minimum foundation depth as 1 meter. And he gave us this formula that if you want to determine the depth D, you will have to get P divided by W into bracket 1 minus sine theta plus divide by 1 plus sine theta, close the bracket, and then you square, whereby the D is the depth. The D is the depth. Then we have P, which is the weight of the structure. And this is actually the weight that the structure will subject to the soil in which it's to be laid on or to be constructed on. And the weight of the structure normally is given in terms of kilonewton per square meter. Then we have the W, which is the unit weight of the soil. And this is also the density of the soil, which is given in terms of kilonewton per cubic meter, but we aren't tied to these units. Actually, you can convert them in case the unit of the structure given and the unit weight of the soil given doesn't actually match. You will have to convert either of them for them to match. You can have Newton per cubic meter, something like that. So, and the angle theta, this is the angle of repose of the soil. And by angle of repose or angle of friction of the soil, what I mean is this. Assume that you have soils whose structures looks like this. Simply the angle of repose is this angle. You see? This angle. This is the angle of repose, which is given as theta. So that is the angle that I'm actually talking about. And you will realize that in these international standards we have the unit weight. You have the unit weight, or simply just the density. I mean the density of the soil, and the density of the dry soil and the wet soil normally varies. You will realize that the density D of dry soil is normally given as from 25 to 35 to 35 kilonewton per cubic meter. That is the density of dry soil. And then the density of the wet soil, I'll denote it as WS, is normally given as, it ranges from around 15 to 25 kilonewton per cubic meter. So simply that is the range from dry soil to wet soil. And normally the dry soil will be given normally the angle of repose of soil, the friction angle of soil is given as 20. The friction angle is normally given as 20 degrees. dry soil, the angle is normally given as 20 degrees. And for the wet soil, you'll be given something like 19.2 degrees. So these are what you work with. Like in our case here, let's go back to our case here. We have been given an example that you're supposed to work out, and the example given is that the structure load, the load of that particular structure is 80 kilonewton per square meter. You have the angle of friction given as 20 degrees, and then we have the soil density given as 16 kilonewton per cubic meter, and you're supposed to work out the to find the depth of the foundation. So let's see how we can get the depth of foundation. Let's see how we can get the depth of foundation. So we can get the depth of foundation. And for us, from the formula given, we have D, depth of foundation will be given by P, that is the weight of the structure, divided by density of soil, to bracket 1 minus sine theta you divide by 1 plus sine theta then you close the bracket and then you square. So in our case we have D. If you want to get the depth of this foundation from the from this example given here, we have the structure load, which is 80 kilonewton per square meter. That is, it's subjecting the weight of 80 kilonewton per every square meter. So divide by the soil density you have been given as 16 kilonewton per cubic meter, then open the bracket, you will have 1 minus sine 20 degrees, then you divide by 1 plus sine 20 degrees, close the bracket, and then you square your answer. So if you work out this one, you will get your answer. If you work out this from your calculator, you'll get your answer as 1.2 meter. So in that case, you'll have to excavate the foundation that is 1.2 meters deep. So thank you. That's how you determine the foundation of the structure that you want to build. So thank you so much. Please remember to subscribe to my YouTube channel. Thank you.